Welcome back, everyone. We're now going to talk about section 13.9 about solutions. These next few videos will speak to the concepts of freezing point depression and boiling point elevation. So what exactly do I mean by those phrases? So if you remember, a solution, that's what this chapter is titled, Solutions. Solutions have a solute, that is a molecule that is dissolved in a liquid that is called a solvent. So solutions can be thought of as homogeneous mixtures. So these concepts of freezing point depression and boiling point elevation speak to what happens to the freezing point or boiling point of a solvent, of a liquid, when you add a solute or some sort of impurity to that liquid. When you add a solute to a solvent, that will lower the temperature at which that pure solvent freezes. That concept is called freezing point depression. It will also raise the temperature at which that pure solvent will boil. So that's called boiling point elevation. So you actually investigated or read about freezing point depression a little bit in the freezing point lab earlier in the course. If you go back and look at that lab, you'll see that you were given data on pure acetic acid, and then you were given data on acetic acid with an impurity, with benzoic acid. If you go back and look at that data, you should see that the sample with the impurity, with the benzoic acid, froze at a lower temperature than the pure acetic acid. That's because of this concept of freezing point depression. Adding an impurity lowers the temperature at which that acetic acid freezes. If you don't remember that, that's fine. We're going to actually do a practice problem regarding those concepts in a subsequent video. The first point of this video is just to introduce this concept of what happens to a solvent when you add an impurity. It will lower the temperature at which it freezes, and it will also raise the temperature at which it boils. Now, how exactly does it do that? How does adding the impurity change the freezing point and the boiling point of a substance? Let's kind of think about these concepts in terms of these cartoons. This cartoon I have here. Let's say I have a sample of acetic acid. And let's say that my liquid solvent, my acetic acid, is the green molecules. If I have a pure liquid sample of acetic acid, those molecules are free to move in between the solid and the liquid phase. It's easy to heat that sample up and to get it to boil. It's also easy for that sample to change states, to go between solid and liquid or between liquid and gas. So that's if you have a pure substance like acetic acid. Now what happens if I go ahead and I add an impurity? And let's say that impurity, like benzoic acid, is these little red dots, these little red spheres. When adding an impurity to a sample, now that impurity sort of gets in the way, as these little black arrows show. That impurity gets in the way of the solvent molecules changing states. So those solvent molecules cannot as easily become a solid or a liquid or a gas. And because that's the case, because those solvent molecules cannot change state as easily because those little red molecules, the solute gets in the way, the consequence of that is to lower the freezing point and raise the boiling point. So that's the why of this phenomenon. In the freezing point lab, if you were to actually do it, in the lab, you would determine experimentally how much the freezing point of a solvent is depressed. You would do that experimentally. Turns out you can calculate how much the freezing point or the boiling point of a pure substance is changed due to the presence of an impurity. We will talk about these two equations in the next video, but you should know that adding a solute to a solvent will lower the final solution's freezing point, raise its final boiling point, and those freezing point depressions and boiling point elevations can both be calculated. And we will talk about how to do that in the next video.